Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Senpai. Welcome back, everyone. Today I'll be giving more math tips for the non-calculated portion of the PSAT. Today's video will be focused on similar triangles. If you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use it to skip ahead to whatever section you find most interesting. If you have any question about what you see here today or even your own homework, remember you can put them in the comment box below or visit me on Facebook at Tutor Me Senpai and tell me all about it there. When you find this video helpful, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Without further ado, let's talk a little bit more about these similar triangles. So when we're discussing geometry questions that may show up on the PSAT, similar triangles is something that comes to mind. So here we have a triangle ABC that is isosceles AB equal to AC. So we're saying this side is equal to this side. We have an isosceles triangle, and we know that BC, this whole length here, is 48. That's what our question tells us. The ratio DE to DF is 5:7. What is the length of DC? So look at this type of question. It might not jump out at you that this may be similar triangles. So my first tip for you today is going to be know what makes triangles similar. Really have an understanding of what makes two triangles similar so that when you see the makings of potentially that, you can start thinking similar triangles. So since our first tip of the day is know what makes triangles similar, we got to know what makes triangles similar. So two triangles are considered similar when the angles of one triangle equal the angles of the other triangle, and if the sides of one triangle are in proportion to the sides of the other triangle. If both these things are true, we say that those two triangles are similar. So we're looking at this diagram that we have a lot of triangles here. Let's see if we can pinpoint any triangles that may be similar. So we're told that this is an isosceles triangle, the big triangle, ABC. But how does that affect our smaller triangles within it? Well, one thing about isosceles triangles is they have two equal angles, right? This side here and this side here are equal, so their corresponding angles are also going to be equal. So we know that angle B is going to be equal to angle C. Well, if we also look at this diagram, you notice that this is supposed to be a right angle, and this is supposed to be a right angle as well. So we know that angle E equals angle F. And writing the angles in this fashion actually leads us to our second tip for today. Map out which angles are equal to each other. If we can map out which angles are equal to each other, that will help us identify the orientation of our two triangles. Sometimes our triangles are going to show up in this weird orientation that doesn't necessarily jump out at us. In this case, it doesn't seem to be a problem, but our next question, you will see what I'm talking about. Since we have two angles from both of these triangles that are equal to each other, we know something about this last angle here. This last angle is going to also be equal to each other. So angle D is going to equal angle D in this case. And the reason being is, if we have two sets of angles that are equal, that third one has to be equal since all the angles in the triangle have to sum to 180. So looking back at our question, it says a little bit more about these sides as well. It says the ratio of DE to DF is going to be 5:7. So these sides are in proportion to each other. So not only are all their angles equal, the sides are starting to be proportional to each other. So if these sides are proportionate, that means these sides are proportionate and these sides are proportionate. And the question is trying to ask us, what is this DC here? We want to ultimately find this line here. So we're going to start setting up our ratios so we can eventually find this DC, which leads me to our third tip for the day. Be careful and consistent when setting up your ratios. You want to make sure that your ratios are being tied to the right triangle. A fraction is only supposed to have one triangle's worth of information and not mixed and matched. So when we set up these ratios, make sure your proper denominator and your proper numerator are going to each one. So we're going to be doing this side over this side is going to be equal to this side over this side. And the reason we don't worry about these sides of the triangles, it doesn't really add any information for what we're trying to find. Since you're trying to find DC, this should be in our proportion. And since they already gave us what the ratio of these two sides are, those are also going to be in our proportion. So we don't need to worry about this outside side because we need to focus on ultimately how to get this DC. So I'm going to move our angles up top so we can write some more stuff down here. So what that looks like is DE over DB equals DF over DC. And we know that DE and DF are in proportion to each other by 5 to 7. So we can actually change that DE to 5 and we can change this DF to 7. But what is our denominators? Well, we don't know what either one of these numbers are, right? But we do know that the total BC is going to be 48. So if we're trying to find this, let's say X, we know that this whole thing is 48. So this right here is going to be 48 minus X. So DB is going to be 48 minus X. And DC is just going to be X. And notice this ratio is tied directly to this triangle, and this ratio is tied directly to that triangle. I'm not mixing and I'm not matching. We want to make sure that each triangle has their own fraction. Well, since we already have our ratios, we don't necessarily need the triangle anymore, so I'm going to rewrite this so we have some more space to actually work out this number. So by doing all this math out here, we get 5x equals 7 times 48 minus x. And when you multiply this out, you get 5x equals 336 minus 7x. And by getting all our x's to one side, we get 12x equals 336. And what is x when we divide both sides by 12? Well, that's going to be 28. So now that we know that x is 28, what is x? Remember how we set this up. X was supposed to be DC. Since we were trying to find what DC was, the length of DC, we simply made it x. And our dB was 48 minus x. Well, since we know what x is, we can stop here. X is 28, so DC is 28. Our answer for this question is 28. However, if you set up your question differently, you could have always swapped these and then had x as dB and 48 minus x as DC. If you did something like that, remember you have one more step. X would not be your answer, you have to plug it back in. However, we set up ours so that x was the length that we were looking for, so we can stop here. So in this question, we have some triangles. It says in the figure above, which of the following ratios has the same value as AB over BC? So for tip 1, know what makes triangles similar. I want you to be thinking, do these triangles have the same angles? Well, it's important to first identify what the triangles are. You have this big triangle ABC, and you have this smaller triangle BCD. So the question is asking which one of these has the same value as AB over BC. So let's start with tip 2. Map out our angles and see which angles are equal to each other. So for our bigger triangle, angle A, we know that it equals the smaller triangle's angle B, just from the numbers, 28 degrees. And because of how this is drawn, we see that angle C is going to be a common angle of both of these triangles. So, by definition, angle C is going to equal angle C from both triangles. And just like we discussed, whenever you have two sets of angles that are equal to each other in these similar triangles, that third angle has to be equal because it all has to sum to 180. So for the bigger triangle, angle B is going to equal angle D of the smaller triangle. So we mapped out our angles. But one thing that mapping out our angles allows us to do, it allows us to also map out which sides are going to correspond to each other. Remember, we're trying to figure out which of the bottom ratios equals AB over BC. So we realize that this ratio is going to be for our big triangle, right? Be careful and consistent when you set up these ratios. Each fraction is supposed to go to one triangle. So this is going to go to our big triangle. So we're going to try to find the corresponding sides for our smaller triangle. And we already said that angle A is going to equal angle B for our smaller triangle. So we can say that A is going to be a B, and this B is going to be this D here. And this B is going to be this D, and this C is going to be that C here. So because we've already mapped out our angles, we can just figure out, without having to try to figure the orientation of this graph, we can substitute what small angle equals our bigger angle and set up our new ratio this way. And when we do that, we get BD over DC, which is answer A. Now, I hope you had fun on today's examples, and I hope you found today's tips helpful. Now, the goal of these tips is to help you save time on the PSAT and to potentially help you avoid some confusion when you're dealing with these questions that can have things shown in some strange ways. If you have questions about what we saw today, or even your own homework, remember you can put them in the comment box below, or visit me on Facebook at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope this helped with your PSAT prep, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.